All right, today we'll be learning about arithmetic sequences. But before we can start that, we have to start by talking about what is a sequence and then what is a series, which kind of have to do with each other. So before we can kind of focus in on this part, we've got to know the basics. The first thing we're going to talk about is what is a sequence. A sequence is just basically an ordered list of numbers. So anytime you see some numbers or pictures, like when you were in elementary school, you saw pictures that were put in a pattern of some sort. Okay, so in this class, we'll be primarily seeing numbers. But like I said, when you were in elementary school, it was more so pictures that they put in an order in some way. So like an example of a sequence would be 2, 4, 6, 8, 10, 12, so on and so forth. Okay, all of your even numbers. And the order, you go from one term to the next, you're just adding 2. Another type of sequence that you may see, and there's many, so this is not the only types of sequences there are, obviously, would be like if we had 3, 6, 12, 24. Well, those are numbers that are put in an order in some way. So your goal with sequences are usually going to be what is the pattern and how do you do stuff or how do you solve problems knowing the pattern. Okay. Another sequence that you may see would be, and it doesn't have to be whole numbers, it could have decimals in it. So like for instance, if we had 0.5 and then 1 and then 1.5 and then 2, that one is put in order in some way. So like I said, your goal is going to be to figure out what is the order and what's the pattern to these numbers. So like for instance, to go from 2 to 4, 4 to 6, 6 to 8, we are adding 2. So the pattern would be that we're adding 2. Here, we're going 3 to 6, 6 to 12, 12 to 24. Well, think about what you would have to do to go from one number to the next. Well, the pattern there is we are actually multiplying by 2. So you don't always have to add the same number to go from one term to the next. A sequence is just the numbers have been put in order in some way. So think about what this pattern would be. Well, to go from 0.5 to 1 and then 1 to 1.5, they are simply adding 0.5, or same thing as 1/2. Now, this is not the only type of sequences we could have. You could have sequences where you divide to go from one number to the next. You could have sequences where you subtract to go from one term to the next. And so there's all kinds of different sequences. There's some sequences, like the Fibonacci sequence, that builds off of its previous terms to go from one term to the next, okay? The next thing that we'll talk about is what a series is. And it's very much related to a sequence because a series is the sum of the terms of a sequence. So remember, sum means that you're adding. So if you start taking these terms in the sequence and you start adding them, then you actually no longer call it a sequence, you now call it a series, which is a little bit of a different topic. So like for instance, I could take this sequence right here and rewrite it as a series. All I'd have to do is start adding the numbers up in that sequence. So when I start adding them together like that, that is now a series. Same thing with this one. If I start with 3 and I start adding it to the other ones, that is now a series. Okay, so those are two big topics, and that actually is the topics that we will be using a lot in the next few days with this class. Okay, so before we can actually dive into this sequence that we will be talking about, we have to talk about some notation. How do they write stuff with the sequence stuff? So one thing that you will see with this is an A with a little subscript of an N, okay? When you see that, it is actually a way that they write a term in the sequence, and they'll call this the nth term. Okay, it's actually a way that they write a general term in the sequence. So I'll put beside it, it's a general term in your sequence. So if they're trying to be in general, take one of these terms from your sequence, they might write it like that instead. Now, something else you need to be aware of is in some of the assignments, you may you might see this written a little bit differently. For instance, instead of A with a subscript of N, you might see it as an A and then a parentheses of N. They will sometimes write it that way, so you've got to get used to that, okay? So then what is this N? Well, this number that's the subscript, so I just wrote it down here, is actually the position of that term in your sequence. And so I'll show you what I mean by that in just a second. So it's the position of the term in your sequence. Okay? So if, for instance, we take one of these sequences that we had up here, so let's take the 2, 4, 6, 8, just so that we can keep it a little bit simple here. If I'm looking at that sequence, I can look at that a bunch of different ways. So for instance, each one of these numbers is what's called a term in my sequence. And if I'm trying to describe just a general term in my sequence, I would label it with an A sub n. But if I was trying to be specific about which term I'm talking about, these terms have a position to them. Like for instance, 2, since it's the first term in that sequence, it would be, the position of it would be 1. 4 is the second term in my sequence, so the position would be 2. Okay, so the way that we write those would be the 2 would be labeled as an A with a little subscript of a 1. So sometimes you'll hear me say for short A sub 1. And then the 4 would be the term in the second spot in my sequence. So it would be A sub 2. The 6 would be my A sub 3 term. And then the 8 would be my A sub 4 term, okay? So something they may ask you in a question is they would say something like, okay, what is the A sub 5 term? That means that they're asking you for the 5th term in that sequence. Well, all you'd have to do, since we already know what the 4th term is find the pattern. And so we discussed that earlier. We were adding 2. So all I'd have to do is add 2 until I get to whichever term. So the 5th term would be the next term. So if I add 2, the 5th term would be 10. Okay, so that's how the notation works. And we will come back to the notation in just a little bit, but that's kind of the basic notation that you have to know. So now we get to talk about what is this type of sequence. What is what's called an arithmetic sequence? Well, it is a very specific type of pattern that it's going to follow. Okay, so that's what this is talking about. It says an arithmetic sequence follows the pattern of adding a fixed amount to go from one term to the next. The number that is added to each term is constant, which means that whatever number that they're adding will always be that number. Okay, it's not going to change. So like if you look up here, this one was an arithmetic sequence because we were adding 2 every single time. Okay, this one is not an arithmetic sequence because we were multiplying by a number. That'll actually be what we talk about in the next couple days, which is called a geometric sequence. This one, because we were adding 0.5 each time, that would make it arithmetic because we're adding a constant number each time. And so that number that you're adding each time, the number like the 0.5 here and the 2 here, has a name. It's called your common difference, and they will usually label that with a D. Okay, so the common difference is the number that's added to go from one term to the next. Now, in certain problems, it may be a little harder to figure out what is the common difference. And so to figure that out, if it is a harder problem and you can't kind of reason through it to find the common difference, all you have to do is take any one of the terms in the sequence, maybe not the first one, you'll see why in a second, but you take a term in the sequence and you just simply subtract the term right before it, the previous term in that sequence. Okay, so like for instance, if I was having a hard time figuring out what number we were adding to go from one term to the next here, all I'd have to do is to find the common difference, I would just take one of the terms, so I could take like for instance 1, and I subtract the term right before it. So I would subtract, well the term right before it is 0.5. So I'd subtract 0.5, and when I do that, my common difference would be 0.5, which is obviously what we had figured out before. Okay, so that is how you find the common difference. So now what do we do when they kind of give us a sequence and we have to find the common difference? Well, that's what we just talked about. So in these problems right here, it says find the common difference and then find the next 3 terms. All right, so to do that, you have to find the pattern first. So the common difference, remember, is like what the pattern is. And by the way, the reason why it's called difference is because of how you find it. You have to take the difference of 2 numbers. Okay, so if I was to find the common difference here, I would take one of its numbers. So for instance, I could take 19 and I would subtract the number right before it. So 19 minus 7. Okay, so 19 minus 7, that would be 12. And so that means the number that I'm adding each time would actually be 12. And you could check it. You could take -5 plus 12 and see if you get 7. And then you could take 7 plus 12 and see if you get 19. And then it wants us to find the next 3 terms. So I would just continue adding that 12. So 19 plus 12 would be 31. 31 plus 12 would be 43. And then 43 plus 12 would be 55. And you could just type that in the calculator if you weren't sure. You can always check yourself. All right, so then the next one, same thing. If I know that this is an arithmetic sequence, then I could go ahead and go to the side and find the common difference. So I would take one of the numbers. So let's say that I take -1, and I would subtract the number right before it. So the number right before that is -12. So it'd be -1 minus -12. So remember, when you have minus a negative, it becomes plus a positive. So when I combine those, I get 11. So that means I'm adding 11 to go from one term to next. So to find the next 3 terms, you just keep adding that number. So 10 plus 11 would be 21. 21 plus 11 would be 32. And then 32 plus 11 would be 43. Okay, so what do we do when it gets to problems like these? Well, it's actually not much different, because if you look in number 3, the R's are not actually changing. The only thing that's changing are the numbers. And so if nothing else is changing but the numbers, just look at the numbers. So this will actually kind of work the same way as the other ones. So if I'm trying to find what the common difference is, I take one of the numbers. So like, let's take the -1, and I subtract the one right before it. So the one right before it would be -4. 2 negatives make a positive. And then when I combine these, I get 3. So I just keep adding 3. All right, so how does that work? Well, R plus 2 plus 3, you just combine your like terms. So 2 plus 3 would be 5. So the next term would be R plus 5. You got to keep that same pattern going. And then the next term, I add 3 again. So it would be R plus 8. And then the last thing, it would be 8 plus 3 again, which would be R plus 11. So notice you've got to keep the R there, because that was kind of part of the pattern. The only thing that was changing were my numbers. All right, and then this last one kind of works the same way. To find the common difference, because the R's are not changing, you take one of the numbers minus the one before it. So let's be creative here, and let's take the 1, and I have to subtract, well, the one right before that would be the 8. So we get -7. So this one's a little different because notice we're subtracting 7. Okay? So this kind of brings me to talk about something here. I said that in arithmetic sequence you have to add a fixed amount. Well, what happens if we add a negative number each time? That's still technically adding. You just happen to be adding a negative number. So with arithmetic sequences, really, it's either that you're adding or subtracting a fixed amount. And so just make sure you remember that if you're subtracting the same number each time, it's still arithmetic, okay? Because that's the same thing as adding a negative number, all right? So just like all the other ones, we have to keep that pattern going. So if we're subtracting 7 each time, I've got to continue to do that. So notice the R stays the way it is. But then 1 minus 7, it'd be R minus 6, because that would be -6. And then I've got to subtract 7 again. So then -6 minus 7 would be -13. So it's R minus 13. And then the last term, subtract 7 again, it would be R minus 20. So there you go. So we will continue this in the next video.